Welcome to John Deere Country Part 3, how John Deere makes tractors. We have a great show for you. We'll visit the John Deere Waterloo tractor, cab, and assembly operations in Waterloo, Iowa. Get on the assembly line with the line operators, visit with some folks who help run the factory, talk to farmers who work with the tractors, and see some great John Deere archival footage. John Deere Country Part 3. Let's get started.
Thousands of people with skillful hands, building hope across the land. Strong machines made with pride throughout the cities and the countryside, putting together dreams one by one, where everyone believes in a job well done. Well, I must be in John Deere country. Well, I must be in John Deere country. In John Deere country. Every part and piece built with care, the best of the best, anywhere. More than just a job that they do, dedicated and proud through and through. Machines that help to get the hard work done. Machines that help to feed everyone. Well, I must be in John Deere country. 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 John Deere country.
John Deere, one of the most recognized and respected brand names on the planet, an icon worldwide. When you say John Deere, you think of the land, the people who work the land, and the green and yellow machines they use: tractors, combines, plows, cultivators, and planters. You think of a company that operates today under the same name it did when it was founded in 1837, of a company that believed in and supported their customers during the Depression. You think of commitment to quality and working hard and feeling proud of producing machines that provide food for folks all around the world. John Deere. John Deere tractors. It started with the Waterloo Boy in 1918. The Model D. The classic A's and B's. John Deere's first diesel, the Model R. The new generation tractors of the 1960s, and in 1959, John Deere's first four-wheel drive tractor. All tractor legends, all laying the foundation for the John Deere tractors of today. Let's talk about the largest tractors John Deere makes, the 9000 series. They are used for both agricultural and construction applications.
Customers for the four-wheel drive tractors, the 9000 series, range anywhere from the production agriculture all the way to dirt moving applications and scraper applications. Anything that has major, large implements to pull, or large towing applications, or in the case of our dirt moving business, building roads, construction sites, things like that.
The 9000 series tractor starts out with the 9230, which generates 325 engine horsepower, and goes up to the 9630, which generates 530 engine horsepower. Within these models, there are both wheel and track versions. Usually, John Deere agriculture equipment is green, and their construction equipment is yellow. But sometimes you'll see a 9630 green tractor beefed up for construction work, working with yellow carry-all scrapers. The main difference between a tractor designed for construction work and a tractor designed for agriculture is the robustness of the frame. The construction tractor's frame is heavier. The hydraulic systems are also different. The requirements for the construction tractor are greater, so they have a higher flow of hydraulics. Large markets of the 9000 series tractors outside of the United States and Canada are Russia, Australia, and Western Europe. Waterloo, Iowa. The John Deere Waterloo tractor, cab, and assembly operations. Let's go inside and see what's going on.
Here at the John Deere Waterloo Works, we really make three basic types of tractors. We make a row crop tractor, which are generally medium to large horsepower tractors that are used for row crops, corn, soybeans, and those type of things. We make a track vehicle that has two rubber tracks, so one on each side of the vehicle that kind of act independently to steer the vehicle, and we make a four-wheel drive tractor. The four-wheel drive tractor is a fixed axle tractor that articulates or kind of pivots in the middle.
If you're involved in some type of a operation that you're tied to the land, chances are we've got a tractor that meets your application and need.
John Deere 7000, 8000, and 9000 series tractors are assembled here. But other locations in Waterloo contribute to the process. Engines come from the John Deere Power Systems in southwest Waterloo. The chassis and axles come from drivetrain operations, also on Westfield Avenue. Castings are supplied by the foundry operation, and designs and plans come from the Product Engineering Center on Ridgeway Avenue. The 18-speed power shift transmission for the four-wheel drive tractors come from the John Deere Coffeyville Works in Coffeyville, Kansas. Other components and parts come from locations all over the world. How do all these parts and assemblies, coming from different locations, some as far away as Hungary, arrive at the main assembly line on time and in the proper order? And to make it even more challenging, there are over 1 million possible configurations. So to make all these parts and assemblies hit the final assembly line in precisely the right order is a major achievement. It all starts with a number.
There is a serial number applied to the rear axle of the tractor, and then think of them as broadcasts are sent to the different sub-assembly areas. That tractor number 1 is going to need a cab on a certain date, it's going to need wheels on a certain date, and it's going to need a chassis on a certain date. And all of that comes together on the final line based on computer systems that are highly integrated throughout not just this factory but across Waterloo in order to deliver the material at the right time. And sequence is critical. The system doesn't work if you launch the tractors 4, 6, 5. They've got to be 4, 5, 6 in order for all of that to come together at the right time.
We start a tractor down our finished chassis line. That serial number of that tractor is then scanned into a barcode system. That, for example, tells the operator over that loads our cabs into the overhead system for all three of our lines. That tells him what order to put that cab in to go to that line.
A sheet listing which options have been ordered, encoded in a barcode, stays on the tractor from start to finish.
That's called a build sheet. Every position and every line we have out here will have a build sheet. That is how these operators and the assemblers know what options that gentleman or lady purchased that tractor. They know what options go with that tractor by that build sheet. That paper tells them what to put on those tractors.
Receiving and moving parts in the most efficient manner receives high priority at the John Deere tractor operations.
We try to optimize the material delivery to really shorten the amount of time that it takes to get from a sub-assembly location to a final assembly location. We talk a lot about non-value added work, and one of the pieces of non-value added work is moving material from one assembly spot to another. So really in an effort to optimize the assembly process, we try to locate the docks. We also try to locate the sub-assembly feeder lines closest to where they will be used on the final assembly line. A good example of that is our cab assembly. It used to be that the cab assembly was done in one part of the building and the final assembly was done in the other part of the building, which required a lot of inventory between those two and also required a lot of movement of that material from the west side of the building to the east side of the building. What we've done recently, the past couple of years, is really co-located those chassis assembly lines to be directly linked to our final assembly lines, and really able to shorten the cycle time of the cab delivery from cab assembly to final assembly, and then also reduce the amount of inventory between the cab assembly and the final assembly. We move some of the components during the assembly process are with bridge cranes. We also have jib cranes similar to a bridge crane. So the overhead devices, either controlled electrically or with air. Those are two ways that we actually power these pieces of equipment. On the tracks vehicle assembly, we actually have a sub-assembly unit for the tracks belt and that tracks undercarriage, and then it's powered by air that actually hoists those over to the main chassis. You'll also see lifts, looks like elevators, throughout the assembly process on our cab line. Most operations can be conducted with the cab at optimal working height, but there are some where we need to work lower on the cab. For an ergonomic standpoint, we need to raise that cab up so it's at a more efficient level. And then occasionally you also see areas where we lower the tractor or the cab down so they can work up on top. And ideally that's to keep the operators in an ergonomic, optimal environment and also keep them safe.
All this is accomplished by a series of highly integrated computer systems, ensuring the delivery of the material at precisely the right time. Let's see how they put together a 9000 series tractor. It starts with the chassis sub-assembly. The front and rear axles, delivered from the drivetrain operation, are combined with the front and rear frames. 2 pins merge the front axle module with the rear frame module. The sandcast part that acts as a pivot between the front and rear halves of the tractor is called a gudgeon. The chassis subassembly is now ready for paint. John Deere Waterloo tractor, cab, and assembly operations has just installed a new multi-million-dollar robotic paint system. Today is a big day for the new paint system, and right now is the big moment. The first 9000 series chassis is about to go through. Jim Wilson, the point man on the new paint installation, was here last night until 3 in the morning, programming the new system for the 9000 series. Since this is the first 9000 chassis to be painted, Jim has his fingers crossed, hoping all will go well. The process starts when the unpainted chassis is pulled to the paint section by a vehicle called a tugger. The chassis is then connected to a conveyor system in the floor. So here we go. The chassis has been thoroughly washed, degreased, rinsed, and dried, and is now ready to have its picture taken. Those bright lights are part of the vision system. The vision system sends the image of the 9000 series chassis to the computer. The computer reads the image, then sends data to the robots, and the robots start painting. But it's not easy. A tractor, with all its curves, angles, and crevices, is difficult to paint. Even computer-controlled robots don't hit every square inch. That's why the paint department has two touch-up guys. Both wearing protective equipment, spray the areas where the robots miss. This is an electrostatic system. Both the paint and the chassis are electrically charged. The paint, which contains a rust preventative, is negative, and the chassis is positive. This system of electrolysis ensures a strong bond between the paint and the surface of the chassis. After touch-up, the chassis moves forward to the post-paint drying and baking cycle. 4 heaters heat the chassis up to 231 degrees. This cures and dries the paint and creates a shiny finish. Then the chassis is cooled, reattached to the tugger, and taken to the final assembly line. This new system is more efficient, gives better coverage, and reduces the paint cycle by 45 minutes. Cure times have also been reduced, and the paint has been improved. So it's all good in the new John Deere tractor, cab, and assembly operations paint department. Great job, Jim. Looks like your late night programming worked just fine. Have you ever wondered where the John Deere green and yellow colors come from? Rumor has it, the idea came from Charles Deere's wife, Mary Little Dickinson Deere.
She particularly liked the changing of the seasons and pointed out that the spring has a beautiful green color to it and all the optimism that brings, and then the pride in the fall of bringing in the harvest and that golden color of a corn. So the green and the yellow represents the spring and the harvest.
At the same time the chassis is going through paint, the cab starts taking shape at the laser cutting station. First, sheet metal tubes are automatically fed into a chamber where a computer-controlled laser cuts the tubes into sections and burns holes into them. Some manual welding is done to the tube sections before they are placed in a special welding fixture. Various components of the cab frame, also known as ROPS or rollover protection structure, are assembled in this machine. After the tube sections are secured, 2 robotic welders spring into action. Quickly and efficiently weld the components together to create a single frame. The cab frame is spun and flipped around to give the robots access to every point requiring a weld. At another station, electrical components are attached and the robots complete the welding. Fastening posts are also installed. These will be used later to mount other components. After the frames are painted black, they go to the cab sub-assembly line. Here, the roof, seat, interior panels, wire harnesses, control panels, All the operator interface controls, drive stick, windows, and doors are all installed. At various points in the cab subassembly, electronic tests are run to ensure all systems are functioning properly. After a final check, the cab is tagged OK and is taken to the final assembly line. Loyalty to John Deere is passed from generation to generation. For many, it started with the Depression. John Deere did not repossess the equipment of farmers who couldn't keep up with their payments. Deere and Company believed in the future and gave their customers extra time to pay.
I was in a field in Kansas and I was visiting with a big customer. He told me that the land that we were standing on would not be in their family had it not been for the John Deere Company in the 30s. And regardless of how proud I was of the equipment and how much he liked the equipment today, it was the loyalty that he was repaying back for the company, that he would always be loyal to the company for what they did for his grandfather. So that it does come into play today in very real terms, the legacy of standing behind our customers through thick and thin.
Employees are as loyal to John Deere as their customers.
I definitely think the link between our employees and our products is incredibly strong. And you know, John Deere, the quote that anyone can quote you from John Deere is that John Deere said, "I will never put my name on a product that does not have in it the best that's in me." And I think we take that to heart every day. And as we're doing that to put into the product, I think it brings us all closer together, and it really helps us form a bond with the people we work with and with the company in general. When we set goals, and as a management team or as a product line, those goals are directly reflected in the goals of our shop floor. And that commitment and the integrity and the team building that we've talked about is really not just at a management level or at a salaried level, it's really throughout the organization.
I think it's because of the treatment that we receive from John Deere, the great working conditions, the good benefits, and the compensation is very good. And it's been passed on, you know, from father to son. It's a great place to work. We have one fourth-generation employee right now on our cab line. A great-grandfather worked here, grandfather, a father, and now she's working on the cab line. We at one time did have a fifth-generation employee at our SPO division. So it's a lot of loyalty. I myself had two brothers that worked here and a nephew. I think probably that's one of the conditions that causes them to come to work for John Deere is the influence of the family.
I think there is a special relationship with tractors and with farm equipment. For one thing, a lot of people have grown up in agriculture. People like to be associated with things of quality. And quality and reliability is a benchmark of the John Deere brand. It's a very significant component that we guard very closely in our manufacturing operations and in our company. I think that resonates with people. People like to be associated with strong brands and those that represent quality. And that's been that way for dating back to the founder of our company.
After leaving paint, the now green chassis is ready for final assembly. The first step in the process is the installation of the hydraulic system. The hoses and steel lines that carry the hydraulic fluid throughout the tractor are put into place. The electrical system used to control the hydraulics is also installed. While the tractor moves down the line, the engine and transmission sub-assembly sections are adding various options called for by the build sheet.
The options that a customer might want to purchase on one of our tractors center around the transmission type, the engine type and size, as well as the hydraulics package, and then some more comfort packages in what's actually in the operator station, the seat, the electronics, the lighting, those type of things.
In the transmission section, pumps, lines, hoses, fans, and alternators are also installed.
We have a few base transmissions that come from our John Deere Coffeyville works. Right at line side, when we launch the chassis, we start trimming out this transmission. The trimming generally means configuring it to that order, that tractor order that we launched at the start of the line. It might mean adding pumps, adding hoses, adding electrical wire harnesses. When that whole transmission module is complete, we drop it into the chassis, and the entire chassis continues on through a similar process with engines. We trim them out and really configure them here next to the line, and then drop onto the assembly line into the chassis.
The various hydraulic and electrical components are connected, and the axles are filled with hydraulic fluid. Rear weights and drive shafts are assembled on line, while the fuel tanks and step assemblies are assembled off the main assembly line.
We continue that way through fuel tanks, cooling packages, steps, all of those things, until we get to our cab assembly area. At the cab assembly area, we take that cab that we finished on our cab line, we download controllers, and what that means is it's moving the software into the tractor. The combination of the controllers and the software is the brain of the tractor. That allows the operator interface, and as the operator controls the tractor, it directs the tractor function.
Farming has changed dramatically in recent years. Farms and equipment have gotten bigger, seeds enhanced, and global positioning satellite technology, or GPS, has radically changed the way farmers operate tractors. John Deere offers their Green Star system for automated precision navigation control. The Green Star system uses GPS to pinpoint the location of a tractor in a field. Orbiting GPS satellites send signals to the Starfire receiver, which is mounted on the top of the cab. The onboard computer is equipped with John Deere's AutoTrack software to plot a precise course for the tractor to run. This benefits the farmer by drastically minimizing overlapping between passes. Plowing and planting are more exact, and the rows are straight. This reduces waste, including seeds and fuel consumption.
The farmers of today are really more businessmen, and our goal in designing equipment is not to make it more complex. The complexity is deeper into the machine. The people that operate the machines can actually do it a lot easier today than in the old days. For example, an operator can hit one button and the tractor drives itself down the road, and the operator becomes more of a sentry to make sure all the gauges are right and just looking back at the planter every once in a while. Where in the days gone by, he had to be making sure that the displays were appropriate and driving the tractor as straight as can be to make sure that the rows are straight. All of that complexity has been removed out of the operator's case due to satellite technology applied to the vehicle. So the vehicle gets more complex, but it's much easier on the operator.
After the cab, computers, the engine air intake, and exhaust subassembly have been installed, the rear fenders are secured. Next, we go to the hood subassembly area, or cell. After the final decals are applied, the hood is hoisted, lowered onto the tractor, and secured. Then the cart moves the tractor to the final assembly station, where the tires are installed. A specialized tire and wheel handler move the fully assembled tires and wheels, with centers and weights, into position on each axle.
We see a lot of options in wheels, and a lot of people think that the wheels and tires are just rubber, black, round things that we put on the tractor. But that is one of the highest options that our customers request. Not only the size of the tire, the width of the tire, even the brand of the tire and the tread style of the tire is critical to our customers with what they do with them in the field.
Once all 4 wheels are secured, the assembly cart is removed and the tractor is driven off the line. A 9000 series tractor can have as many as 12 wheels. More wheels means the weight of the tractor is distributed over a greater area. This reduces soil compaction and increases traction. John Deere also offers a track vehicle. Track tractors ride on a pair of continuous tracks, which displace the weight more evenly, minimizing compacting the ground and offering better mobility on softer ground.
The customers who are interested in a Trax vehicle are concerned about the compaction of the soil. If you think about a Trax vehicle versus a wheel leaves a very small patch of actual contact between the tractor and the ground. So the compaction of the soil is greater. You have a larger patch when you have a Trax vehicle, so you really distribute the pressure from the weight of the tractor onto the soil more, which means you have less compaction of the soil. They do have a different steering system. It's much more of a steer-by-wire, so you could literally do a 360-degree turn in it with the belts just spinning in opposite directions. Compaction of the soil is a key variable for many customers, and it gets right back to the productivity and the efficiencies of their operations. Customers are very much concerned about how many seeds per inch in order to maximize their output. And so if compaction is greater, the yields from those products is reduced. And so that's one of the reasons why compaction is an issue.
Just like tractor wheels, tracks have a series of chevron-shaped treads providing traction. The teeth on the inside of the track secure it to idler wheels, called bogies, and 2 large pairs of outer wheels. First, the bogie undercarriage is installed onto the tractor chassis. The large outer wheels are installed onto the drive axle. Sections of fish plate brackets are bolted to the axle to secure the wheels. The rear axle provides the drive. The rubber track, weighing 1,800 pounds, is placed on an air-powered manipulator that holds and stretches the track. The manipulator is pushed to the tractor, and the track is aligned around and over the axles and bogie undercarriage. After the front wheel is secured, the manipulator relaxes its hold on the track, which then fits tightly on the undercarriage. The manipulator is pulled away, and workers finish tightening various components. John Deere is celebrating the 50th anniversary of their 4-wheel drive articulated tractors. Their first, numbered 8010, was introduced in the fall of 1959, 1 year before John Deere introduced their new generation tractors. Let's go back in time and let legendary CBS newscaster Walter Cronkite help introduce the 8010.
And now for one of the most popular and interesting features of the John Deere program each year, the report on What's New.
Newest and biggest wheel tractor on the market is this 8010, a four-wheel drive diesel with 218 horsepower under the hood. Big, yes, built for the really big jobs, but oh so easy to handle. Watch how its brand new floating action 3-point hitch takes hold of integral equipment. You simply back into position, touch the hydraulic lift lever, and away you go. And what's this? A brand new integral plow with 8 bottoms. Yes, count them. It takes real power and stability to lift and carry this biggest integral plow ever built. A lumbering giant? Not on your life. A fast-stepping husky that will roll up to 18 miles per hour in transport. Power steering makes the 8010 a breeze to handle. Yes, here's a new diesel tractor built for the big acreages. A tractor that will cut costs, put more working capacity in the hands of one man. Together, they make a ground working team that's sure to pay dividends in faster work, lower costs.
Only 100 8010s were produced. In 1960, the model number was changed to 8020. The 8020 was a good idea, but it was a little ahead of its time. The average size of farms was getting bigger, but still not big enough to need a tractor as big as the 8020. Today, 62 of the original 100 8020s are in the hands of collectors. This is Bill Donner of Three Oaks, Michigan. Bill is doing one of his favorite things, driving his totally restored 8020. Some of you may remember Bill from previous John Deere videos.
The four-wheel drive tractor really is in reference to the rear axle and the front axle, both having power to them all the time. You'll commonly see those four-wheel drive tractors with actually 2 and sometimes 3 wheels on each of the 4 corners.
The four-wheel drives started in 1959, and this year we're celebrating our 50th year in the four-wheel drive business. And it's gone from 215 horsepower all the way up to 530 horsepower today. I think the original four-wheel drive was 16,000 pounds, and today they're over 50,000 pounds in weight.
Agriculture in the 21st century has evolved from a family farm of 100 to 200 acres to corporations farming thousands of acres. This new area of fewer, larger, more industrialized farms has demanded bigger, smarter, and faster equipment.
Average sized farms have grown, but also within those farms, the yields have increased dramatically as well due to technology of the seeds and other advancements in the agriculture realm. In general, growers have gotten bigger. They've gotten attention to more detail through technology to reduce variation on their operations, and they've honed in on ways to increase yields, decrease cost, and more accurately hit the harvesting and planting windows to optimize that yield. Pre-70s, 200 acres or so could be farmed very easily with a typical tractor. Today it's very common to have 2,000 acres to be farmed by a traditional tractor made out of Waterloo Works here. So a scale of 10 times the amount of land could be easily farmed with today's tractors. There's been 2 major changes on the productivity per day in today's tractors versus the tractors that are made 20, 30 years ago. Number 1, comfort and convenience and the onslaught of automation, automated guidance in our vehicles today allow growers to run 24 hours a day. and they can cover thousands of acres, depending on what their application is, in a single day. You could not do that 30 years ago due to the manual nature of the work and the smaller implements. That just was not possible. Today you can cover thousands of acres in a single day, and at the end of that day the operator feels a lot better because most of that time the tractor has been driven by itself or through the satellite technology. The large and extra large farmers of today have been consolidating and getting bigger. The traditional grower is what I would term the family farming segment, has not so much gone away as it has changed in its dynamics. There's still a lot of people that farm traditional amounts of land, 500 to 1,000 acres, let's say. The difference is today they might have a second job or an off-the-farm income to supplement that. But the numbers are that a sizable amount of our business goes to the traditional segment, and those numbers are sustaining right now.
Implements have increased in size along with the farm.
Large plows, field cultivators, disking operations, as well as we've come out with a 120-foot planter. If you can imagine 120 feet across the field being planted in one pass, whereas 20 or 30 years ago that would take 3 or 4 tractors and 3 or 4 planters. That's done today with one of those four-wheel drives and one planter.
Quality control plays a major role in the assembly process. After assembly and initial startup, each tractor is then driven, inspected, and goes through a full functional check. One interesting check to watch is the tractor backing up a 30-degree grade. The various quality checks, both during and after the assembly process, have changed.
We used to do them all manually. It used to be a clipboard and a paper, and an inspector would make sure that each one of the functions were checked off. Over the past 3 years, we've really evolved more into an automated state where we're able to capture more data. We're able to improve the quality of the calibrations of the hydraulics and of the electronics, and really improve the quality of the checks that we do along the way. And some of that data that we've collected then, we've been able to take back, feed to design engineering, and actually improve the tractor and improve the first pass yield of our tractors. One check specifically that we do at the end of the assembly line is the electronic release test. It consists of about 200 electronic checks to make sure everything from the lights to the windshield wipers to the transmission are all calibrated correctly and in proper working order before delivery to the customer. And just with the implementation of that tool alone, we've been able to reduce our low hour warranty claims to our customer up to 20%, I think, just in the first couple months of implementation of that tool. Those electronic checks are done at various spots along the way. Ideally, we find the problem at the closest to the source that it occurs in. So you will find testing and diagnostic devices throughout the assembly process. Each subassembly, their key characteristics need to be checked and in some cases tested before going on to the next step. And then at the end of the assembly line, we have one large test and a drive audit. So each one of our tractors is actually driven for one final check before it's shipped.
It's called a black light oil leak test. We do that 4 times minimum on every tractor. We do not want a tractor leaving Waterloo, Iowa with an oil leak. That's a no-no. Now down on the 9000 series, that tractor synchronizes itself. We go in there, we program that with a laptop computer, put it in, we program it, we start it up. It will synchronize itself down on the 9000 large four-wheel drive.
A final drive test is performed on the test track. When everything checks out okay, the tractor is signed off on. This indicates the tractor has been tested and is ready for shipment. Some institutions in America generate intense loyalty and respect, even from those who have no official connection with the institution, like the United States Marine Corps and the University of Notre Dame. Many folks feel the same way about John Deere.
I think people understand
the Waterloo Tractor, Cab, and Assembly Operations throws a gold key party for those buyers who want to see their tractor being built.
Every person that purchases a tractor here from John Deere Waterloo Works and the Tractor and Cab Assembly Operations has the opportunity to come on a gold key tour. The customer can actually come in and watch their tractor be built and go through the final assembly process here. And a lot of the times the customer has the opportunity to be the first one to start the tractor and drive it off the line. I think the fact that they have the opportunity to see the process and see their specific tractor being built, that's just a huge event in their life.
it's really a milestone in their life, because most of these farmers, when they come in, it's a day away from the farm, and their time is very important on the farm because they're 24/7. It's not like a 8 to 5 job. They take time away from their work and they bring their family in, and it's a family occasion. It's kind of like a mini vacation because it ties them up for about 2 days, sometimes 3 days, depending on how far away they have to travel. So it's a memorable experience that many of them write that they'll never forget. They write it on the survey sheet when they send it back. And I guess the biggest impression they have is that they get to go right on the line, rub shoulders with the operator, talk to the operators on the line. They get to see how every piece goes together on their tractor. And it's just amazing the feedback we get.
About 33,000 folks take the Waterloo plant tour every year.
Most of them are amazed. There's a lot of folks think that this is a snap-together toy. And when they come in here and they actually see what it takes to produce our product, they're amazed. And they are very amazed at the cleanliness of our buildings. You keep your own work area safe and clean at all times. And people are amazed how clean we keep it.
John Deere listens to both their employees and their customers.
And every Wednesday, the entire factory stops. And for a half hour, we go over the quality data, we go over efficiency data with those natural work groups in order to get ideas from the operators on the shop floor. Quite honestly, they're the ones that are the experts in how those tractors go together. They'll know how it goes together more efficiently. They'll know how to really build quality into the product. So that half-hour break that we take on a weekly basis is really a chance to stop production, talk with the guys on the line, and get their ideas, turn those into projects that we use to improve the quality and the efficiency of the products.
Customers also contribute vital information that helps shape product development.
We have many processes to get the feedback from our customers. Voice of the customer is one process that we use that is a team, from operations, marketing, design, engineering, to really listen to what they have to say and build that into the next generation of products. The operators on the shop floor have better opportunity to meet with their customers than most of the folks in our marketing department. On an annual basis, they will see more customers than folks in our marketing department will. And that's some of the best opportunities to really get the candid feedback from the customers as to what they think about the current product, what they'd like to see in the next generation product. So we have a variety of ways to really get input from the customers, and one of the most unique ones from the factory standpoint is the Gold Key program.
All the tractors waiting to be shipped and all tractors in the assembly process have been special ordered by dealers or customers in America, Canada, and 130 other countries all over the world. Those to be shipped overseas leave Waterloo by rail. Those going to dealers are loaded and delivered on flatbed trucks. Some dealers, usually those close by, send their own flatbeds. Then, after installing various options, deliver the tractor directly to their customer's farm. John Deere is making plans for the future.
As we went into this year in our goal setting sessions, every year when we set our factory goals and our department goals, we talk about safety, quality, delivery, and efficiency. And this year, one of our goals around safety has really been to shrink our footprint as a corporation. And that's driven down from the corporation all the way down to our factory level. So we are taking steps in the production of our tractors to make sure that we are lessening our footprint and continuing to become more green as we evolve, both as assembly processes, machining processes, foundry, all of those things.
Today have approved a biodiesel for the tractors that come out of this factory. We're looking at more flexible type fuel options in the future to go forward with that. In general, we want to make sure that as that technology advances in fuels, that our equipment is leading that, or at least available at the time of that fuel being approved for use in diesel engines. Business is great, experienced some great times here the last few years, true advances in productivity, and customers have rewarded us with some of our designs with increased business, and we feel very good about the future of agriculture and our customers. And when we feel good about our customers and agriculture, clearly that directly impacts our business. We love it. We love our tractors and we love the people that drive them.
Thanks for watching. Hope you enjoyed the show.
Thousands of people with skillful hands, building hope across the land. Strong machines made with pride throughout the cities and the countryside, putting together dreams one by one, where everyone believes in a job well done. Well, I must be John Deere country. Well, I must be in John Deere country, in John Deere country. Every part and piece built with care, the best of the best, anywhere. More than just a job that they do, dedicated and proud through and through. Machines that help to get the hard work done. Machines that help to feed everyone. Well, I must be in John Deere country. Well, I must be in John Deere country. Well, I must be John Deere country. Well, I must be John Deere country, John Deere country.
John Deere Country Part 1. How the John Deere Combine is made. Ride along for a rare and fascinating look inside the John Deere Harvester Works. See how they make the John Deere Combine. Follow each step of the operation: metal fabrication, paint, welding, sub-assemblies, main assembly, final inspection, to combines being loaded on trucks and flat cars for delivery all over the world. Bonus features include rare, archival footage of the first self-propelled John Deere combines, starting with the 55s introduced in the late 1940s. 1 hour and 20 minutes of great family entertainment.
Everyone knows that yellow and green.
All About John Deere, Parts 1, 2, 3, and 4. 4 40-minute DVDs. Featuring irresistible Johnny Poppers from the past, plus the latest and greatest from John Deere. Big four-wheel drive tractors, amazing combines, planters, you name it, you'll see it in All About John Deere. All About John Deere, Parts 1, 2, 3, and 4. Great entertainment for the entire family. All new from TM, John Deere Earth Mover Action. Like big earth-moving machines? Then buy this DVD because it has them all. Excavators, front-end loaders, graders, scrapers, backhoes and dozers, including John Deere's newest, the super fast, super powerful 4-track 764. See all these big, rugged machines in action, digging dirt, plowing snow in the Rockies, loading big articulated dump trucks, climbing hills, plowing through rocks. Powerful, big-time earth mover action that will thrill and delight young and old alike. See lots of Ertl die-cast toys, mining candy at the Big Rock Candy Mountain Quarry. All new music by award-winning singer-songwriter James Coffey, plus lots of interesting facts so kids learn, laugh, and want more. All new John Deere Earth Mover Action. Prepare to be amazed. From the creators of All About John Deere and John Deere Action comes a new series aimed at the preschool set, Fun on the Farm. We'll talk about the growing season. You'll see tractors, new and old, planting, cultivating, combines harvesting the crops. We'll visit a farm right in the middle of a big city, see how John Deere makes combines, visit a pizza farm, and play the cloud game. You'll be amazed at what you can find in the sky. You'll meet our pals, Doodle Rooster, Bell Cow, and Harvey Horse. Plus 9 new songs by James Coffey, including the Wacky Farm song and Old MacDonald Had a Farm. So come on along for guaranteed fun and laughs. You'll see lots of tractors, farm animals, steam engines, combines, and you'll learn a lot. I know I did. Till then,
this factory at Moline, Illinois, builds John Deere plows, listers, cultivators, disc tillers, and drag harrows. Here is the planter factory in Moline, the largest in the world. Planters, disc harrows, and stalk cutters are its products. The John Deere Wagon Works at Moline builds wagons, trucks, and high-speed farm truck trailers. In East Moline is the John Deere Harvester Works, where binders, mowers, sulky rakes, corn pickers, threshers, and combines are built. Close by is the Spreader Works, where manure spreaders, corn shellers, elevators, and cotton harvesters are built. And not far away is this John Deere factory, manufacturing malleable iron castings and other parts for all John Deere machines. At Ottumwa, Iowa, John Deere side delivery rakes, hay loaders, sweep rakes, stackers, and hay presses are manufactured. Chilled plows, spring-tooth harrows, and potato planters and diggers are the products of this factory in Syracuse, New York. John Deere Van Brunt drills, field cultivators, lime and fertilizer sowers are built in this factory at Horicon, Wisconsin. And now for the largest of all John Deere factories, the Tractor Works at Waterloo, Iowa, about which this motion picture is mainly concerned. But before going farther with our story, let us pause and pay tribute to John Deere workmen, whose ruling pride down through the years has been quality first. Their loyalty to purpose, building quality implements to match the needs of the times, has made possible this growth from one anvil to the 10 great factories you have just seen. Let's go up with this flyer and from the air get a better view of this tractor plant, which covers more than 75 acres of floor space. This factory was purchased by John Deere back in 1918. As a result of a constantly growing farm demand for its products, the size of this plant has been increased fourfold since its purchase. 4 railroads with switch tracks running into the plant deliver John Deere tractors and engines to every agricultural section of this country. In these storage yards, thousands of tons of steel, iron, coke, sand, fuel, oil, and other materials are unloaded and stored for use in manufacturing John Deere tractors. This powerful traveling crane, capable of picking up 12,000 pounds at one time, unloads the materials from freight cars to piles and bins. Here it goes, up to the charging floor of the cupolas. The operator directs the loaded magnet over the proper bin, cuts off the electricity, and the load is dropped. On this charging deck of the furnaces, materials are carefully weighed to ensure high-quality castings. Precision in the manufacture of John Deere tractors starts with the raw ingredients. The quality of the materials is determined early in the process of manufacture of John Deere tractors. This is the laboratory with its staff of chemists and metallurgists who devote their entire time in analyzing and testing the various materials. Now back to the furnaces where raw materials are converted into molten metal. From this charging deck, alternate layers of coke, iron, and other materials are dumped into the cupola. And here on the ground floor, the molten metal flows like water from the furnace. Nickel alloy is added, especially for cylinder castings, to ensure long-wearing qualities. This inspector, looking through the spectroscope, accurately determines the temperature of the iron by its color. And from each ladleful of molten iron, a sample is taken to make a test bar, which is rushed to the laboratory for analysis. Each of these ladles, holding more than a ton of molten metal, is moved from furnace to foundry at high speed by means of small motor trucks. We are now in the foundry, which is the destination of the fast-moving trucks as they move away from the furnaces with their ladles of molten iron. 125 tons of molten metal is poured daily into various sizes and types of castings. Here we see the iron being poured into a mold which makes the transmission case for a Model A tractor. Skilled workmen with years of foundry experience carefully control the pouring of the metal to produce perfect castings of uniform thickness and strength. These castings go to the milling room where they are cleaned in huge revolving tumblers. But there are metal seams and rough edges that must be ground away inside and out. This workman is cleaning up the case with a portable emery wheel, preparatory to the first operation in the machine shop. In the foreground, an inspector is looking for imperfections. Too bad to throw out such a large casting, but out it goes if it isn't perfect. Now the heavy machine shop and more transmission cases. 3 gigantic 50-ton machines perform the first operation. At this end, the 6 revolving roughing cutters cut away the metal on 3 sides at one time. As the case continues forward, the 6 finishing cutters on the other end leave the rough cut surfaces smooth and true. The case now goes to the boring machine, where 11 large holes are bored and reamed at one time. From this reamer, the case goes to the gang drilling machine, where 68 holes are drilled all at one time to ensure accuracy. Here's a corner of one of several machine shops containing hundreds of ingenious machines required in the building of John Deere tractors.
Gee, it's some factory, Dad.
Let's watch the machining of the crankshaft. But first, we are going to find out if the shaft has the proper hardness. This machine exerts terrific pressure, and by the size of the mark left by this machine, the hardness of the shaft is determined. Having passed the hardness test, the sturdy, heavy crankshaft is now ready for the rough cut operation. And now for the first machine operation, the rough cutting of the main bearings. A gang of 4 cutters working as one remove their quota of the surplus metal before the crankshaft goes to the next machine. This machine rough cuts the connecting rod journals on the crankshaft, an ingenious machine that cuts as it revolves. Finally, we get to the finishing operations. This machine almost talks. At least it tells the operator through the sensitive dial to 1/1000th of an inch when bearings have been ground to exact size. When the dial reaches 0, the operator stops the machine and with his own gauge checks the diameter of the bearing. What, more inspection? Yes, sirree. Nary a crankshaft gets into a John Deere tractor without the main bearings being carefully checked with this sensitive instrument, and the 2 connecting rod bearings with master gauges at this inspection station. Here we see on a delicate electrical instrument the balancing of the crankshaft to eliminate vibration. The sparks tell the operator where the crankshaft is out of balance. Then the located surplus metal causing out of balance is removed by drilling, and when balance is perfected, no sparks appear. This is the gear department, where thousands of steel forgings are made into long, live machine-cut gears. On this machine, the gear teeth are accurately shaped. 8 dimensions on each tooth are cut by a series of perfectly timed mechanical movements. All gears used in John Deere tractors are hardened. This is the immersion process. The battery of electric furnaces heat the gears to correct temperature. They are placed in a hydraulic press and held in place under tons of pressure. Each gear comes out round, true, and properly hardened. Gears used in John Deere tractors are tested for hardness by the scleroscope. First, let's test a hardened gear. Watch the little ball bounce as it drops on a hardened tooth. Up it goes to 90 points. A test of real hardness. Watch the ball as it drops on a soft gear. There is little or no rebound. This cylinder boring machine performs 3 operations at one time. It rough cuts, bores, and reams the cylinders in successive steps. And now for the honing operation. Honing the cylinders, like the many other operations, is performed by skilled workmen. Experience and craftsmanship on this job play a most important part in turning out cylinders of correct size and proper finish for most efficient tractor operation. At this station, you see the inspector checking cylinder blocks. With all the uncanny accuracy of the machines that perform the various operations, each important operation is carefully checked before it goes on to the next step in tractor building. Here is where the pistons in John Deere tractors are accurately machined. Let's move closer to one of these machines, where we will watch for a moment the cutting of the grooves for the 5 piston rings. John Deere tractors have 5 rings. The lower one, which is the wiper ring, and now the inspectors get into the picture again. Every piston goes through this careful inspection procedure. All pistons are checked with gauges for size and roundness. The ring grooves and piston pinhole are checked for size and fit, after which each piston must pass a test for weight. Now we're in the wheel department, where wheels of various sizes and widths are manufactured for John Deere tractors. You're right. This machine sure is a whopper. It weighs more than 100 tons, sets on a 22-foot concrete foundation, and in operation exerts a pressure of 365 tons. You see it punching 96 holes at one time in the heavy steel tire stock. Next, you see the rolling, welding, and trimming of the weld of the wheel tire. In the background, the tire plate is rolled into a circle. From here, it goes to the welder, where the ends are welded together by electricity. Fireworks all day long here. Every day seems like the 4th of July. In less time than you can tell about it, the welding operation is complete. Here we see the pouring of the cast hub around the spokes. The wheel is placed in a molding machine and molten metal poured in to form the hub. And now for the machining of the wheel hub, which is bored, reamed, and drilled all at one time by this specially built machine. By means of a revolving turntable, the operator changes the position of the wheels after each different operation is performed. Let's stop a moment and see the forming of spade lugs used on tractor wheels. After being blanked or cut out of flat stock, the slabs are heated red hot and put into this forging press. These slabs of heavy metal under terrific pressure bend like tin to perfectly form a spade lug. Next, we're going to heat treat these lugs. They must be properly hardened to give John Deere tractor owners long service. From this revolving furnace, the heated lugs are hardened by immersion. In this large assembly room, John Deere tractors are put together. You have just seen the Model D assembly line. This is the general purpose assembly line. And here is the Model A being assembled. Assembling a tractor is an interesting operation, so let's follow the Model A and see it completely assembled. Here we see the cylinder block being attached to the transmission case. Moving along a little further, we see that the transmission gears mounted on ball or roller bearings are in place. The operator is now putting in the sturdy differential unit. Here the crankshaft goes into place. It's about all one man can handle. We are now ready for the pistons and connecting rods. But before they go into the tractor, they must accurately line up, and the weight of each pair must be accurately balanced. See how perfectly each piston with its connecting rod balances the other. The manifold now goes on the tractor, while one of several assembly line inspectors checks the valves for proper clearance. The sensitive governor, which has been previously tested, is now put into place. This shows the assembling of the rear axle unit. Notice that the large rear axle casting is one single piece. The rear axle shaft, almost 3 inches in diameter, is carried on roller bearings at both ends. The axles and bearings are held in perfect alignment by the one-piece casting. The final drive gear, made of forged steel and hardened, completes the rear axle assembly. After the rear axle assembly is completed, careful inspection again takes place. After it is okayed, it is attached to the tractor. The rear axle cover gasket is next put on, followed by the rear axle cover, which makes a dust-proof, oil-tight enclosure. Gradually, the tractor begins to take form as the radiator is put into place. Notice that the core is encased in an iron frame, making it especially sturdy to withstand hard service. And now, to prevent engine wear and promote long life, a highly efficient oil type of air cleaner is installed. The wheels, which you saw manufactured in the wheel shop, are now placed on the splined rear axle shaft to the narrow or plowing position. And now you see a finished John Deere Model A tractor. But will it run? Let's see. After the operator puts in fuel, oil, and water, he belts it to the electric starting motor. Puts the tractor in gear, throws in the clutch, out it goes under its own power to the test room, where you see the breaking-in test of John Deere tractors. This is the first chance for the various John Deere tractor parts to really get acquainted with each other. These tractors are being carefully checked over by skilled workmen after the breaking-in test. They may find the tractors well broken in and in A1 running order, but their power and fuel consumption must be accurately checked before the tractor goes into your hands. Let's move on to the next line where the horsepower and fuel consumption are determined. Through accurate recording instruments, varying and full loads are applied by the electric dynamometers overhead. The dial at the left registers the horsepower. The fuel gauge in the center shows the amount of fuel used per horsepower hour. Power and fuel economy must be proven before a John Deere tractor gets into your hands. But there are other tests that are also mighty important to you. Tests made on John Deere's own proving grounds. Before any new model John Deere tractor goes into factory production, its principles of design are proved in the field through thousands of hours of use under heavy loads and severe conditions like these. Conditions that are more severe by far than any model will undergo in actual farm use. Here we see tractors being washed to take off all the grease. Then they are dried before going into the paint booth. Then, completely covered with the John Deere green and yellow protective coats of paint, the tractor is now ready for the drying tunnel. At the other end of the drying tunnel, we find the tractor emerging for final inspection, which takes place here. The carburetor, engine speed, and other parts are examined, and operations are checked. Passing the final inspection, the tag of approval is tied to the steering wheel, and the name John Deere, which has stood for quality farm equipment for nearly 100 years, is proudly put on the hood. These tractors have all passed most rigid inspection throughout their manufacture. They have passed numerous tests to prove their ability to perform efficiently and economically. And now, this quality product, built to produce money-making as well as money-saving farm power, is on its way to you. In order that you may receive it in the same perfect condition as it leaves the factory, it is loaded in a boxcar which is sealed for safe delivery to your town.
Tractor sales hit a new high, and the John Deere Tractor Works grew to be the largest single factory of its kind in the world. Today, this huge plant occupies a total floor space of nearly 40 acres. It has grown from a small machine shop in 1892 to the sprawling giant you see here because of strict adherence to one policy down through the years, the policy of building quality products that made farm life easier and more profitable. To maintain that standard of quality and to give farmers the benefit of new manufacturing methods and new materials has required constant and costly changes in factory equipment. Getting down closer to this great factory, we see a beehive of activity. Men and machines are at work building into John Deere tractors the qualities you want in your tractor, the qualities that made possible this tremendous growth. Let's go inside and get a glimpse of what's going on. A corps of engineers is constantly at work, drawing plans for improvement of John Deere tractors. It is their job to keep John Deere ahead of the field. Battery upon battery of machines costing hundreds of thousands of dollars cut and shape the hardened gears and other machine parts. Row upon row of other machines costing more thousands of dollars are manned by highly skilled workmen who have been trained in their crafts, workmen who take pride in maintaining the high John Deere standard of quality on every job they do. All the way from the vast foundry where tons of metal are poured into castings every day to the finished product, keen-eyed inspectors watch every part and every assembly to be sure it fully meets required standards. When completed, each tractor is given a final inspection and thorough test before it is okayed for delivery to you. This final step is your assurance of satisfactory performance, no matter which one of the 18 models of John Deere tractors you buy.
into the night. And all through the day, the cupolas in the foundries of the two great John Deere tractor factories dramatically symbolize the production of today's modern farm tractors. From the earth have come huge stockpiles of metals, coke, and limestone that are lifted by electric cranes and mixed for the yawning mouths of the furnaces. Out of the cupola flows the molten metal at 2,850 degrees Fahrenheit. An alloying agent is added to produce the desired qualities in the castings. From the mixer, it pours into huge ladles that will be carried to the foundry pouring areas on overhead tramways. Here is a new $2.5 million foundry unit at the Waterloo Tractor Works. This huge installation was made for one purpose: to assure production of uniform, top-quality castings. The molding sand that's being rammed and jogged into the flasks is prepared as precisely as is the batter you'd mix for a cake. Pure ingredients and proper moisture content assure perfect contact with the pattern, which is underneath the sand. Powerful steel arms flip the flasks bottom side up, exposing the molded sand ready for the coring operation. Skilled workmen carefully lay the cores into proper position in the molds. Impressions in the mold will form the outside walls of the castings. The cores, the inside shapes of the castings. Precision placement of the cores and removal of excess grains of sand by compressed air assure highest quality in the finished parts. Here, the top section of the mold joins the bottom section. They are then locked together to form the complete flask and move on to the pouring floor. Molten metal delivered from the cupola at the proper temperature flows around the cores, filling the patterned areas to form the castings. The largest casting produced in the plant is the one-piece transmission and differential case for the 4010 tractor. In this massive milling machine, both sides and the top of the case are rough cut, then finished, assuring parallel mounting and perfect alignment of all parts in the transmission and final drive. As much as 30 pounds of metal may be removed in this operation. From the milling machine, the casting is moved to this automatic drilling machine, where all holes will be drilled simultaneously. Further assurance of perfect alignment of all transmission and drive parts. 87 drills bore holes to exact size and location. At the Dubuque plant, the 2010 tractor transmission case is drilled with the same care. 68 holes are drilled in all four sides of the case. Precision manufacturing like this means more years of trouble-free performance from all John Deere tractors. Castings such as this clutch and flywheel housing are thoroughly cleaned to remove every metal chip and other foreign matter that might interfere with perfect functioning of the tractor. Top-quality gears that sparkle like jewels flow from the new and modern equipment in this gear cutting department. 3 transmission gears are cut progressively from high-quality forged steel blanks. Electronic controls remove the guesswork in cutting gears to precise requirements. Each tooth is cut as accurately as the teeth in the gears of your watch. Only the most modern equipment can do a job like this, cutting the spline for the final drive gear on a rear axle. Constant inspection and checking of gears is a part of quality manufacture. This sensitive instrument is feeling the surface of a helical-cut gear tooth to be sure its angle is exactly right. It records its findings on this graph paper as it moves along the surface of the tooth. This is but one of the many hundred quality checks in John Deere tractor production. The faces of the teeth on this ring gear need to be hard for long wear, while the inner core remains tough to withstand shock. Induction hardening produces this condition. Electrical energy brings the teeth to red-hot temperature. Quick quenching in oil completes the hardening of the teeth surfaces. The completed transmission with all gears in place is thoroughly tested and approved before it goes to the assembly line. It is operated in each gear under varying loads and speeds to be sure all parts are functioning properly. The engine block is manufactured with the same precision as is the transmission case. Here, oil passages for pressure lubrication for each of the 7 crankshaft journals in a 4010 diesel tractor are drilled simultaneously. This assures that filtered oil will be supplied positively to the journals when the engine is operating. All main bearing journals and the camshaft bearings are precision bored in one operation. This assures perfect alignment for smooth performance and long life. Extra heavy, sturdy crankshafts always have been a feature of John Deere tractors. Here, a forging for a 4010 diesel crankshaft starts its long trip to perfection. A punch tape signals electronic controls which accurately guide the cutting tools in this first machining operation. This grinding operation on the crankshaft smooths up the main bearing surfaces. Precision drilling of holes in the crankshaft assures positive distribution of lubricating oil under pressure from the main bearings to the connecting rod bearings. Each crankshaft bearing surface is induction hardened to the proper depth for long wear. Body of the shaft retains its elasticity to absorb shocks. The bearing surfaces are quenched by a liquid spray at the proper instant. The hardened bearing surfaces are now ground to a mirror-like finish for smoother operation over the years. Dial gauges indicate when the correct size has been reached. This is the final operation in manufacturing a 3010 crankshaft, getting it in perfect balance dynamically. The dial shows the location of the excess metal that's causing out of balance. Drills controlled by the operator remove the amount indicated. The dial now shows the crankshaft in perfect balance, ready for vibrationless performance in a 3010 tractor. Accurately made pistons are a must in a quality-built tractor. That's why John Deere aluminum pistons are produced under the most modern quality control procedures. They are cam ground to rigid specifications, then checked with an air gauge. Each piston is carefully inspected and checked for size and shape to assure dependable performance. This modern machine is honing the inside walls of wet-type cylinder sleeves, 3 at a time. The alert operator checks each liner with a sensitive gauge to be sure its inside surface will have the proper clearance for the piston it will contain. Engines are assembled in this spotlessly clean area by skilled workmen, each trained for a specific operation. Each installs a part or performs a function as the engines move along the line carried on an overhead conveyor. with the sturdy, heavy-ribbed cylinder block of a 4010 diesel turned upside down, the crankshaft is carefully laid into the bearing surfaces. Then the heavy main bearing caps are put in place. 1, 2, 3, 4, 5, 6, 7 main bearings in a 4010 diesel. With a dual electric wrench, both bearing cap screws are tightened at the same time for an accurate fit. To further assure exactly the same tension on all cap screws, torque wrenches are used in all assembly operations where proper tension is critical. With the engine block turned right side up, the wet-type cylinder sleeves are inserted. The ever-present inspector checks the job. At this station, efficient workmen team up to install the pistons. One man inserts the pistons and rods, while the other attaches and tightens the connecting rod caps. A special tool compresses the rings uniformly to assure proper insertion of the piston. Water-washed air under pressure flows into this assembly building to keep outside dust and dirt from entering. When the engine is completely assembled, it is given a thorough overall inspection before it is okayed and sent to the test room for rigid run-in tests. Every engine must prove its readiness for the assembly line before it leaves this test room. When it first comes to life, it is run at 1900 revolutions per minute for 15 minutes to flush out its internal parts by a continuous flow of fresh oil through the engine. Then comes 70 minutes of operation at varying loads and speeds under the careful observation of engineers. This engine is producing more than 80 horsepower at 2200 RPM, and its fuel consumption is checked. After rigid inspection and careful final adjustment, it is ready to wait its turn on the assembly line. First major unit to go downstairs to the line is the transmission assembly. It has been tested, inspected, and run in as a unit. Down it comes to the busy assembly area, where everyone knows his job and does it well. A carrier on the constantly moving line receives the case, which will grow to a completed 4010 tractor. Here begins the assembly of the final drive with placement of gears in the differential case. The rear axle housings with the planetary final drive gears installed swing into place for attachment to the transmission case. Extra rugged strength is apparent in all drive parts. From the test floor above comes the heart of the tractor, the engine. It could be a diesel, gas, or LP gas engine, since all three types of 4010s are assembled on this line. At this important station, two basic units, engine and transmission, are bolted and sealed together for life. The hydraulic pump, which furnishes the pressure for all hydraulic functions, is attached directly to the end of the crankshaft. Here again, a torque wrench is used for final tightening to assure exactly the right pressure on the bolts. Toward the end of the bustling line, the assembled units and parts take on the look of a finished tractor. The fuel tank is put in place. One of the many inspectors on the line checks the PTO operating lever. The instrument panel, delivered to the line by the endless conveyor in the background, is put in place and connected to its many sources of information. This is the end of the line, where oil, water, and fuel are added. The engine is started, and the final assembly line inspection is completed. A few feet away from the 4010 line is the 3010 assembly line. The same great care in manufacturing and assembling assures the same high-quality performance in both of these field-proved tractors. With its coat of green and yellow paint and rubber tires all around, a new John Deere moves in for the last assembly operation. Attachment of the deluxe posture seat, the greatest advancement in design for comfort ever made in a farm tractor. At the Dubuque plant, a 2010 tractor is put through its paces for the inspector, who gives it the final okay. It is checked in each of the forward and reverse gears at varying speeds to be sure engine and transmission are functioning properly. As the row crop model moves into the shipping area, a 2010 row crop utility moves up for its final check. All sizes and types of John Deere tractors must meet the same extremely high standards of performance. Every tractor bearing the John Deere name must have in it the most modern design, the best materials available, and the most careful workmanship.
We're at the John Deere Tractor Works in Waterloo, Iowa, to ask the experts, the design engineers, what makes the 55 series tractors so popular.
There's lots of reasons. There's more torque, better fuel economy, and greater comfort. The 55 series are the best we've ever built. We've built a worldwide reputation for quality and reliability at John Deere.
What about the engines in these tractors?
The new 7.6-liter engine in the 55 series tractors may not look much different from the outside, but inside it's a whole new story. At the heart of the new engine is a new piston design. We've literally redesigned the combustion system. The piston has a much larger diameter combustion bowl. It is now centered underneath the injection nozzle to promote much better air-fuel mixture during the combustion process. In fact, at the higher power levels associated with the 7.6-liter engine, we were actually running lower temperatures and pressures than on our previous 466 engine. The proof of the 7.6-liter engine fuel efficiency is right here with this unit. When this unit was tested at Nebraska, it was the most fuel-efficient tractor ever tested at max PTO power.
We know about the long testing hours on the mechanical front-wheel drive and the tight turning of caster action with the automatic engaging-disengaging system. But what else is new?
The MFWD is automatically engaged to give four-wheel drive-like braking anytime speeds are greater than 9 miles per hour and both brakes are depressed. Stopping is as important as starting. This additional braking capacity is a real safety plus. In the automatic mode, at speeds above 9 miles per hour, the MFWD automatically disengages to reduce tire wear by as much as 50%.
What about improvements to the famous sound guard body?
What we were able to do is, when we took away our old seals, we were able to open up the window frame, so to speak, and take advantage of that with state-of-the-art urethane bonding. So we do have better visibility, particularly in areas where you need it, in the lower front quadrants, around the wheels, row crop areas. If the customer is more comfortable, he's going to be more productive. And things like the seat, if he can be more comfortable, more relaxed, change his position, the IntelliTrack instrumentation, he can really tell what that vehicle is doing, what his slip is, peak it out for peak performance and efficiency, fuel efficiency, that type of thing. I think if somebody really wants to get a feel for that, they need to get in a cab, get in a 55 series and get out and drive it, and they'll find out.
Looking for real tractor value? We have 6 models from 105 to 200 horsepower. But you don't have to come to Waterloo, Iowa to get one. You can order one here right after the show.
A simple modular design that takes a no-nonsense approach to your big power needs. John Deere 60 Series tractors. 3 fuel-efficient models sized for the big jobs. 235 horsepower, 300 horsepower, and the giant powerhouse, 370 horsepower strong. All 3 models utilize cooler intake air and high-volume combustion to deliver high torque, constant power performance. And each is equipped with a thermostatically controlled viscous fan drive for matched cooling efficiency. You get the power you need with up to 10% more fuel-saving economy compared to previous models. They're easy on your wallet, easy on you. John Deere's Sound Guard body helps soften the hard knocks of a long day. You get the feel of open-air visibility with the pleasures of peace and comfort. Plus, you can keep track of your progress and productivity. IntelliTrack instrumentation keeps you fully informed of vital tractor functions. An optional radar system also provides true ground speed and wheel slip percentage. And productive. These 60 series tractors are top-notch performers in any notch you're in. In fact, this optional 24-speed transmission even lets you shift on the go in both speeds and ranges. What's more, John Deere 60 series tractors are very simple to service. Daily maintenance takes less than 2 minutes. 3 tractor models with high torque, fuel-efficient power. Sound Guard body. Shift on the go transmission.